Good morning, children. How are you all? Fine? Okay. Today we are going to start our chemistry session with the topic physical changes. All of you open your book. Those who don't have the book, please stay on video itself. Okay, students, in physical change, it is easily understood that there is no change in the mass of a substance when it undergoes a physical change. When a substance undergoes a physical change, there is no change of mass. For example, the mass of an electric bulb does not change after it remains lighted for the same time. If the bulb lighted for some time, its mass does not change. Similarly, a given mass of ice on melting gives the same mass of water. And a given mass of water on boiling gives the same mass of water vapor. Okay? In physical change, there is no change in mass. And now we are going to discuss about chemical change. According to the law of conservation of mass, in a chemical change, the sum of the masses of the reactants is the same as that of the products. In chemical change too, the sum of the masses of the reactants is same as that of the products. We must look at the total mass of the substance before and after the reaction. So we can conclude that in chemical changes also mass of the reactants of the substance is equal to mass of the products. Okay. Let us consider burning of a piece of paper. During the process, it appears that there is a loss of mass, but that is not the case. In fact, while burning, the paper takes up oxygen from air and forms some ash plus carbon dioxide and water vapor. Actually, the time of burning, the paper takes up oxygen from air and forms some ash plus carbon dioxide and water vapor. So we have to see whether or not the mass of paper plus oxygen taken from air is equal to that of the ash plus carbon dioxide and water vapor. A detailed experiment shows that the two masses are equal. Means masses of paper plus oxygen is equal to mass of ash plus carbon dioxide plus water vapor. Okay, you can verify the law with the help of a more simple experiment as described here. One more experiment we can discuss. Put a small tube or bottle containing a solution of barium chloride into the conical flask. Place some sulfate solution. In the flask with the help of a dropper carefully, ensuring that the two substances do not come in contact with each other. To confirm that the two substances, sulfate solution and barium chloride, should not come contact with each other. Close the mouth of the flask with a cork and weigh the flask. Tilt the flask and swirl it slowly. A white precipitate is formed. Leave the flask for some time and weigh it again. You will find that there is no change in the weight of the flask. Okay. Here is the just have a look in this diagram for this experiment. It shows the conversion of mass in the reaction between sodium sulfate and barium chloride. So dear children, it is the end of our chapter. Now we are going to discuss few question answers which are left yesterday. Please open your book. Now we will discuss the question number 5. State the law of conservation of mass. Please underline law of conservation of mass and mark the next line, mark from here to here. Matter can neither be created nor destroyed, but can be changed from one form to another, and the total mass of the substance before and after the change remains the same. Okay. Our last question from long answer part. Describe an experiment which proves that law of conservation of mass. Please open page number 4 and mark the experiment. From here to put a small tube or bottle containing a solution of barium chloride into a conical flask. Place some sodium sulfate solution in the flask with the help of a dropper carefully, ensuring that the two substances do not come in contact with each other. Close the mouth of the flask with a cork and weigh the flask. Tilt the flask and swirl it slowly. A white precipitate is formed. Leave the flask for some time and weigh it again. You will find that there is no change in the weight of the flask. Okay, and draw this diagram for this answer. Please draw this diagram. Now we will start objective questions. Our first question is, choose the correct option. Which of the following statements is correct? Option B is the correct answer. Option B, intermolecular force is the strongest in the solid state. Now second question, which of the following statements is false? Option A is the correct answer. The kinetic energy of particles decreases with the increasing temperature. Now fill in the blanks. The intermolecular space in a substance dash with increasing intermolecular force. Second option, decreases, is the correct answer. Now second one, evaporation of a liquid is faster at dash temperatures. Higher is the correct answer. Please tick it. And third one, a gas is compressed easily because of its dash intermolecular space. Large is the correct answer. Please tick it. Fourth one, among ice, water and water vapor, the intermolecular force is the dash in water vapor. Answer is weakest. Please mark it. Now the kinetic energy of a particle dash on cooling. Please mark decreases. Okay, our fill in the blanks portion is over. Now we will discuss true or false part. First question is, a liquid does not evaporate below its boiling point. Answer is false. Second question is, the collision among the particles in a liquid causes it to evaporate. Answer is true. Third one, when a substance is heated, the kinetic energy of the particles decreases. False. Then when a solid is heated, its particle vibrates more vigorously. True. There is practically no decrease in the total mass of the substance in a chemical reaction. Answer is true. At last, burning does not obey the law of conservation of mass. False. Okay, students. Our first chapter is completed. Thank you for your cooperation. Okay, our first chapter is completed. Question answers already given to you. Please learn it carefully and ready for the exam. Okay, this chapter is very important for you. Okay, stay home, stay safe, and have a nice day.